Welcome back to SimVisuals 2 configuration. This is part 2, which is the final configuration. In part 1, we covered adding projectors for single IG, multiple IG, and also for spanned and non-spanned displays. In part 2, we'll have a look at the screen definition, the layout of the projectors, adding cameras and fiducial points, control points, the alignment pattern, and defining the content type. It's worth noting that cameras and fiducial points is for AutoCal only. So let's jump across to the user interface and we'll have a look at where we were last time. So we were adding our projectors and I've got our 3 projectors added there. So we'll just go down to screen and now we can click add screen. Here we can give our screen a name. This is helpful if we've got multiple screens, so we might say that this is the cylinder screen. Here we can define the shape of our screen. We can choose between flat, cylindrical, spherical, and conical. So with a flat screen, we can define the width and the height in linear measurements. At the moment, SimVisuals is configured for meters, but you can change that and configure other metric and imperial measurements. With cylindrical screens, we can measure our horizontal field of view in degrees and our height and radius in linear measurements. With spherical screens, our horizontal field of view is again in degrees, and our top and bottom values are also in degrees, relative to the equator of the screen. So if the top is above the horizon or the equator, we put a positive measurement, and if the bottom is below the horizon, we put a negative measurement in. And then our radius is in linear measurements again. Then with conical screens, which are very similar to cylindrical screens, our horizontal field of view is again in degrees. Now we have a top radius and a bottom radius, so we have two radii there. In our case, our screen is cylindrical. It is 180 degrees. Our height is 2.4 and our radius is 3 meters. The position and rotation is important if we're working with multiple screens and we're looking to use real-world 3D mapping. This allows us to position each screen relative to a world origin, and then we can also position an eye point relative to that as well. So in our case, we'll leave this cylindrical screen at a position of 0, 0, 0 and a rotation of 0, 0, 0, so it's going to be at the world origin. We can add multiple screens, so we can go through and add a second screen now. So say we have floor projection, we could call this the floor. It'll be a flat floor and we can put our width in, so our cylindrical screen is 3 meter radius, so our floor screen might be 6 meters. And then the height maybe 3 meters if we're only going halfway. So then we would put a position and rotation in, so we would have a pitch rotation of 90 degrees to put that on the floor, and then our position offset will be 1.5 meters. So now we have our 2 screens there. Now we have our design eye position, and this is where we can set the eye point relative to the screens and the world origin. So say we have a flight simulator and we're looking to set the eye point up for the captain who sits on the left. We'll want a left-right translation of the eye point, and we'll say that that might be 0.3 meters. So we'll go negative 0.3 meters, which will move the eye point over to the left. And then we can press update. So that's setting the screen and also the design eye position. Let's have a look at layout. The layout allows us to position projectors relative to the screen. So we have a layout for each screen. Let's have a look at our cylinder layout. We'll press the pencil icon on that line. Here we can choose between a grid layout and an auto layout. In most cases we have grid layouts, so let's have a look at that one first. We'll click configure layout, and now we can choose whether we have a horizontal grid or a vertical grid. A horizontal grid allows us to have varying columns for each row, and a vertical grid allows us to have varying rows for each column. So let's add our first row. In our case, we have 1 row of projectors and we have 3 columns. So we'll make this say 3, So this is where you would measure your projector overlap. There's some information in our user guide on how to measure and calculate your projector overlaps. In our case, our overlap is 20%. This can also be specified in pixels if you wish. Let's click Update, and now you can see a representation of our layout. We have 3 projectors in one row. Now we can assign our projectors to each of these cells. In our case, when we specified our projectors, we did so from left to right, so we can simply go down the list here and assign our projectors left to right as well. Now we can click Update. So that's the grid layout set up for our cylinder screen. Let's have a look at doing an auto layout now. So an auto layout requires no configuration, other than selecting which projectors belong to this auto layout. SimVisuals will then, using geometrically aware tools such as AutoCal or RapidCal, will automatically work out where each projector is on the screen surface. It'll also then calculate the overlapping areas between each projector. Now let's have a look at cameras. Cameras are required for our camera-based AutoCal calibration system. Let's click on Add Camera. Here we can select our camera type. We support USB cameras, IP cameras, and GigE cameras. For each camera, we need to know the lens profile to be able to underdistort the image that's coming from the camera. Because of this, we have a small list of cameras that we support. However, we can easily calibrate further cameras by request. In this case, let's select the Logitech C920. Now that we've told SimVisuals which lens profile we're using, we can select which node the camera is connected to. In our case, we only have one node, and then we can select our camera. In our case, we've got 2 cameras, so I'll go through the process again. So now our 2 cameras are added. Let's have a look at the process for IP cameras. If we choose IP cameras, again we select our model. Here we can put in our IP address for the camera. The port will normally stay the same, and then username and password if authentication is on the camera. Let's have a look at the process for GigE cameras. Here we'll choose the camera model, which gives us our lens information. And then in this drop down, we'll have our list of GigE cameras if they're connected to your network. So now we've got our cameras specified, let's have a look at fiducial points. Fiducial points are known locations on the physical screen that AutoCal uses to understand the camera's position relative to the screen, and also some information about the screen edge and position. SimVisuals has enough information about our screen for it to automatically generate some fiducial points for us. So let's click the Generate Fiducial Points button and then click Continue. Here we have a representation of our cylinder screen with 0 degrees in the middle, and -90 on this side and +90 on this side. We need 6 fiducial points per camera. In our case, we have 2 cameras, so each camera can see 6 fiducial points. The 2 cameras are sharing the 0 degree point. In some cases, due to occlusions or screen geometry, you may need to remove some of these default points and add new points. You can simply add new fiducial points by clicking the Add Fiducial Point button and then specifying the coordinates horizontal and vertical. You can also edit or delete existing fiducial points in the table below. So let's have a look at control points. The control points page is broken up into 2 sections. The top section is warp control points, which are the points that are used for manual calibration. For manual calibration, we start with a default of 2 columns and 2 rows, which gives you a control point in each corner of each projector. You can dynamically add or remove more columns and rows during the calibration using keyboard shortcuts. The bottom section here is RapidCal control points, which is used with our RapidCal calibration. RapidCal points represent physical locations on the screen. What we need to do is take our screen surface and divide it up into columns and rows of control points. We do this to allow us to have 6 points per projector. An easy way to work this out is to take the number of projectors and multiply by 2. This will give us 6 columns that we're going to break our screen up into. If we take our overall horizontal field of view of 180 degrees and divide by 6, we end up with 30 degrees. So let's set our column width at 30 degrees. And here you'll see that it's giving us 7 control point columns. So that's our 6 sections that we've broken up the screen into, plus an end column at the end of the screen. For our row height, what we might do is divide this by 2, and that will give us a control point at the top of the screen, one in the middle of the screen around the equator, and then one at the bottom of the screen. So we'll go ahead and put 1.2 meters in there. And there you can see that's giving us our 3 rows. So now what we have is we're going to have a control point every 30 degrees horizontally. We're going to have a control point every 1.2 meters vertically. So now what we need to do is go to our physical screen and place markers on the screen every 30 degrees horizontally and also every 1.2 meters vertically. An easy way to work out 30 degrees for a curved screen is to measure a chord distance. You can calculate the chord distance if the radius of your screen is known, and there's some further help in our user guide on how to do this. So let's have a look at the alignment pattern now. Here we can choose between different alignment patterns that we'll see on the screen when we're doing our calibration. We have the choice of a checker pattern, solid color, or a custom image. Let's have a look at checker pattern. Here we can define the size of the rows and columns in our checker pattern. If we press the edit icon here, you can see a preview of what our checker pattern will look like. We can change the columns and the rows depending on how many projectors we have. So in our case, we have 3 projectors. So what I'm going to do is I'm going to get our 32 and multiply that by 3, and that will give us 96. And you'll see on the preview now that we have a lot more columns, and this will represent our 3 projectors. The line columns and line rows adjust the size of the black lines. If we have a look at solid color, this allows us to pick different solid colors that would be displayed on the screen, usually for testing. We can also add custom colors down the bottom here. You can specify these in RGB or hex values, and they'll show up down the bottom. We also have the ability to upload a custom image. You can upload a PNG or JPEG file to each projector, which will be shown whilst doing the alignment. Typically we'll be using the checker pattern, so let's change it back to that. Now we can have a look at our content type. SimVisual supports 2 types of projection mapping. We have 2D mapping, which will fit the desktop to the screen shape and size. This is useful for desktop applications, photos and videos. The other mapping mode is 3D mapping. We call this real-world mapping. This is useful for simulation software and in 3D environments. After you've completed your calibration, SimVisuals will provide frustum values for virtual cameras that represent each projector in your system. This information can be provided to image generation software to create multiple viewports that represent these frustums. Alternatively, if you're using 3D software, you can create virtual cameras that represent these frustums. SimVisuals will then map these frustums onto your screen surface, giving you a seamless and geometrically accurate out-the-window view. If we change our layout over to grid, we'll be able to see this in action. Here we can see the various frustum values required for each virtual camera. As we've moved our eye point over to the left, you can see that these values are not symmetrical across each projector. This is intended and will allow SimVisuals to give you an accurate point of view from that eye point. Join us in our next video where we'll begin the calibration process. If you have any questions, please reach out to sales@immersiveview.com. Thanks for watching.